Good morning, students. Welcome to chemistry class. We are studying chapter number 4, Periodicity of Elements, in which we have already discussed the arrangement and the classification of elements by different scientists, which is Dobrinier triad, law of octaves, and Luther-Meyer classification. Today we will see that how Mendeleev's periodic table is different from modern periodic table and how Mendeleev's periodic law is the key for unlocking the mysteries of atomic structure and chemical bonding. Mendeleev's classification. First of all, let me ask you a question. Do you know which element is number 101 on the periodic table? It is called Mendeleevium, after the name of the scientist Mendeleev, who considered as father of periodic table. As we know that new ideas change the world, so did Mendeleev's idea. It was a huge step forward in arranging and classifying the elements in the periodic table. Mendeleev, a Russian chemist, arranged the elements in order of increasing atomic mass, placing the elements with similar chemical properties vertically beneath each other. He observed that the properties of the elements with slight modification or with a very little difference repeated themselves at intervals, which we already have discussed, that the periodicity of elements. So he proposed the law that the physical and chemical properties of elements are a periodic function of their atomic weights or atomic masses. Remember that only 63 elements were discovered at that time, and Mendeleev was looking at the relation between atomic mass of elements and their physical and chemical properties. Now, what is the atomic mass of an element? The mass of one atom of an element. And the SI unit of atomic mass is kilogram. But since the atom is really small, a more convenient unit called atomic mass unit or AMU is used. For example, hydrogen is 1 AMU and carbon is 12 AMU. Now, what are physical properties? The physical property of element are like density, melting point, boiling point. And the chemical properties are basically how an element reacts with other elements. The periodic table published by Mendeleev consisted of 8 vertical columns called groups, that is, group 1 to group 8, and 12 horizontal rows called series, which were later known as periods in the modern periodic table. Now, if you closely look at Mendeleev's periodic table, you will find something really interesting. Can you see some gaps in there? This was the genius of Mendeleev, his sheer brilliance, because he didn't forcefully try to fit the elements in his table, but he left gaps for the elements, as only 63 elements were present at that time. So he boldly predicted about the discoveries of some new elements. And when the new elements were discovered, they exactly fit into the Mendeleev's periodic table, where the gaps are already present for those elements, and the properties of those elements were also matched with the predicted properties of the Mendeleev. Now, salient features of the Mendeleev's periodic table. Number one, It has 8 vertical columns called groups and 12 horizontal rows called series or periods. Number 2. Elements in each vertical column have similar properties. Number 3. Vacant spaces were left for the element not discovered until then. Spaces were left for the unknown elements with atomic masses 44, 68, 72 and 100. He proposed their names as eka-boron, eka-aluminium and eka-silicon. Eka is a Sanskrit word for one. So first comes aluminium and then this unknown element. And he predicted the properties of eka-aluminium also. Number 4. The group number indicates the highest valence number that can be attained by elements of that group. Now, what are the advantages or the importance of Mendeleev's periodic table in that era, which leads towards the classification of the elements in the modern periodic table, especially when after the discovery of gallium, which was previously known as eka-aluminium by Mendeleev, the scientific community was surprised that Mendeleev knew the properties of this new element, gallium, better than the chemist who has discovered and the new element gallium, which was called by Mendeleev eka-aluminium, so named because it occupied the first vacant space in his periodic table under aluminium. The periodic table of Mendeleev helped in systematic study of elements. For example, the study of sodium, which is alkali metal, helps in predicting the properties of other alkali metals such as potassium, rubidium, cesium. And the concept of periodicity was highly satisfied with the Mendeleev's arrangement. In his periodic table, Mendeleev leave the vacant spaces for the elements to be discovered later on. So, the prediction of new elements was made possible by him. The physical and chemical properties of eka-boron, eka-aluminium and eka-silicon were predicted by Mendeleev. This helped in their discovery. These have been named as scandium, gallium and germanium. Their properties are remarkably matched with the properties predicted by Mendeleev. Mendeleev's periodic table also helped in correcting many doubtful atomic masses. Although Mendeleev's periodic table was of immense importance, but there were some limitations in the periodic table, which are there are 3 pairs of elements of higher atomic masses placed before elements of lower atomic masses. That are argon 40 placed before potassium, that is 39. So potassium should be before argon as the atomic mass of potassium is 39, but he placed argon before potassium. Number 2, cobalt 59.9 placed before nickel, which is 58.6. Tellurium 127.6 placed before iodine, that is 126.9. And another limitation was there was no place for isotopes of elements. Actually, isotopes were discovered much later after Mendeleev's table was proposed. So there wasn't any space or any discussion about the isotopes of the element, and we know that isotopes of an element have similar chemical properties but different atomic masses. Another shortcoming of the Mendeleev's periodic table was he placed dissimilar elements in the same group. For example, alkali metals lithium, sodium, potassium, rubidium, cesium and francium were placed with coinage metals like silver, gold, and copper. Similar elements placed in different groups, for example, barium and lead, resemble in many properties, but they are placed in separate groups. Also, it failed to give the idea of atomic structure. And we know that the modern periodic table is depending on atomic structure of the elements. So, it was all about the Mendeleev periodic law and periodic table arrangement of elements and the shortcomings and the importance of the Mendeleev periodic table. In the next class, we'll move towards the modern periodic table. Till then, I request you all to please study from your textbook, complete your notes, and must learn whatever you have studied. Thank you so much.